Hi everyone, this is Kanaga Sabapati. So welcome to the DevOps GitHub Series 3. So today we are going to see predominantly three main topics: branching, pull request, and how to overcome merge conflict, and how to resolve that merge conflict as well. So yeah, in the GitHub Series 2, we have discussed about the Git branches and some of the basic commands. So this is a kind of a continuation of that series. So if you have not gone through that series yet, so please go through DevOps GitHub Series 2. So you will get some good understanding of Git. So yeah, coming to here about the branch. So why do we need a branch in Git? So basically, branch enables the parallel development. What does mean by parallel development? Let's consider uh, in a kind of a typical development scenario. So we have a lot of developers who will be working on separate changes or separate features, right? So one will be doing, let's consider a automobile uh, project as an example here. And you are doing some kind of a engine development or something like that. So in that engine development, like one person will be working on some feature called like how to control the input output channels kind of thing, and some other developer will be working on the stability metrics, right? So this is a kind of a two separate path. So we need some kind of a place where all the developer can contribute their code to a central hub. So that is where we need a branch. So when we have a branch, each individual developers will be working in a kind of isolated fashion on their respective future, on their respective requirement. So once they are ready, they will be pushing their codes to the central hub. That means on a branch. Okay. So here, whenever you create a new rep in GitHub, by default, main branch will be created for you. So this is the default branch in GitHub. But still you can develop your own branches uh, based on your requirement or your project needs, and you can merge your branch to the main branch. So we'll see that in detail in further slides. Before that, like, we just want to highlight you like what are the type of branches we have. So but this is just a kind of a best practices, but still, yeah, like there are a lot of strategies followed in different project, but we would like to highlight some of the industry like mostly followed industry best practices. Okay, so here we have long-lived branches and short-lived branches. What is long-lived branch? As the name indicates, that branch live forever. The branches like main, which reflects the production state of the code, is a kind of a is a type of a long-lived branch. Also, like we have something like an integration branch. Integration branch is nothing but like a release branch. In a normal development or deployment scenario, we'll be having an integration branch where we need to pick only very few changes and make it to the release branch and deploy that branch to the respective instance. Okay, so mainly these two branch serves as a long-lived branch, and this branch will stay forever, and like yeah, it will not be deleted in a normal use case. Okay, on the other hand, we have short-lived branches. Short-lived branches is something like a future branch. We could say future branch, as the name indicates, like some of the future you are working on. You could have naming convention like future hyphen the name of the future you're working on, or the version number, something like that. So future branch and patch release branch. Patch release branch in the sense like in production, if you have encountered some serious issue and you want to fix that bug immediately, so you can right away create a short-lived branch with the name like hotfix or patch release, something like that. And yeah, you can merge the code change to main and deploy to production. These are all contribute to short-lived branch strategy. So short-lived branch can be deleted. Like once you merge your code to the base branch, you can delete your branch immediately. So that we will show you later, like how to do a merging kind of things. So basically, like here we have covered two scenarios. One is scenario 1 and scenario 2. Scenario 1, we are going to talk about like how our developers have to work in a fashion like without disturbing the mainstream, how they can develop their new code changes and merge to the mainstream. Okay, so here in the illustration, the pictorial representation, you could see we have a project root folder. So that root folder contains a folder called source, subfolder called source src, and a file called readme.md. And also this subfolder src contains index.html. Okay, so this is the content of the main folder. This is the mainstream. Let's consider this is the mainstream branch, and this has got two commits, commit 1 and commit 2. So here developer A comes in and he wants to or she wants to develop a feature called, let's consider feature X. Okay, for that he or she has to introduce some more changes to this project root directory or project directory. Let's consider he wants to or she wants to introduce the HTML file called aboutus.html. So this is the new file he or she is going to add to that project folder through commit 3. Okay, so what she or he can do, so without directly updating his code changes in the main branch, what he can do, he can clone future branch, or he can clone the content from future main branch, and he can name that branch as a future branch. Okay, just like a cloning contents of main branch, and he is going to name that branch as a future branch, and he or she is trying to make all the changes to the future branch, and finally this future branch gets merged to main branch through pull request. Okay, so this is the scenario 1 or use case 1. Okay, so now there is the scenario 2, which is like we have deployed a code to the production. At some point of time, there is a severe bug identified in the production, and we need to address that bug, or we need a fix for that fix for that production issue. So what we can do, so similarly we can clone, like as we said, like main branch always reflects the production code. So we can clone the main branch and we can name that branch as a hotfix branch or feature branch, uh, like our patch branch. Okay, so we can name that branch and immediately start developing the bug fix for that issue, and we can include that commits to that branch and merge that branch to the main branch to pull request and release it to or deploy it to production. So as shown in the picture here, on the right side, you could see hotfix patch or feature branch that has commit 1 to commit 4.5, not commit 3, because future branch is something different and this hotfix branch is something different. So these two are isolated. Hotfix patch or feature branch doesn't have commit 3. Okay, so it got only commit 4 and 5. This clearly indicates, like on the branch level, we are isolating the code changes. Okay, so whenever you switch the branch, you are not having all the changes which are all made on the other branch. So it's kind of a clearly and entirely isolated copy of a branch. That is the cloned branch. Okay, so that's why like the branching is more powerful in Git. So similarly, like other version controls also got the same strategy like SVN kind of thing, but predominantly we are focusing Git here. So yeah, so this is how we the branching strategy works in the Git and GitHub. Okay, so next, like Srihari will be explaining about the pull request part, like why do we need a pull request and why it plays a very major role in merging a code from branch to branch. Over to you, Srihari.
Thank you, Sabha. So with the explanation provided by Sabapati, we understood the purpose of branch. All right. Now we are moving to, we have the branches, we have a parallel environment or a parallel stream of space to develop an isolated way, and each has its own purpose. And also the branches, the types of branches that are being created depends on the branching strategy which we are following. So that also a typical separate session will be covered for branching strategy in later. Now, if the parallel development activity is complete or it reaches a matured stage, and the mainstream has to get merged with the new development activities. So to do that, the feature that we have in GitHub or Git is the pull request method. So the pull request is nothing but to incorporate the changes that have been developed in a separate branch or workspace to the mainstream, or vice versa, or wherever you want to merge between two branches. Also, this facilitates the individuals who contributed to the code, either the author or any other team member who is the stakeholder of that particular functionality, can review the code, mutually agree, and then merge the code. So these three things like review, merging, resolving the conflicts all happens via this feature called pull request. All right. So now let's take a use case. So now we are going to do an exercise, and using that exercise, we'll be able to understand the pull request model. All right. Let's take a simple use case where there is a main branch, all right, and there is a new feature branch is created. And when there is a development activity going in the feature branch, it's going to merge to the main branch. We are creating a pull request, and the pull request is reviewed by the author, and the pull request is created by the author and reviewed by the reviewer, and then it is merged. Let's take an example. So this is a repo that we are going to take as an example. In this repo, if we see, by default, there is a main branch, and this particular repo has a source directory, and inside source directory, there is an index.html. So now we know that main has the main page change. That's it. Now I'm going to, a new developer wants to start his activity, to create a new branch. So the base branch is the main here because the feature is created from main branch. Now, by default, the feature branch is created from the main branch because we were inside the main branch. So if we create any branch, new branch, sitting on that branch, the new branch will be created from the branch from where we are creating as a base branch. For example, if from sitting from feature branch, if I create F2, so it will automatically make feature as the base branch and then F2 will be created. So just to explain that, now in feature branch, I'm making a change from feature and I'm committing to the feature branch. So if you see here, the feature branch has the feature change. And if I go to main branch, only main page change. Now, if I create a pull request to merge the changes from the feature to main, new pull request. So base branch where I want to push my changes remains as main and the compare branch will go as feature. So the feature contents is compared to the base main. On top of main, it will be compared and it will be pushed to the main branch. Create a pull request. I'm going to add a reviewer. So in some cases, we need to make the branch as protected. Otherwise, there are chances that we may skip this review and merge to the main. That's administration activity to make the branch protected so that without a review, it will not merge the code to the main branch. So now in this case, we are going to add the reviewer as a best practice. So I'm asking the reviewer whatever the business justification you can add here and create the pull request. So the review has been requested. If the branch is protected without the reviewer giving a review here, I will not be able to merge the pull request. Now let's ask Sabha to review it. Automatically an email notification will be sent with this link to Sabhabadi for review. Now with the notification, Sabha already approved. So you can see that approval here. I'm going to merge the pull request, confirm merge. So now in this case, the changes we made to the feature branch got merged to the main branch. So if I go to main branch, I see the changes from the feature. So this completes the use case one, right? So the detailed steps also covered in this Medium page. The link will be shared below the video. Now coming to the use case two. So this use case will also cover the vanilla. The use case one covered the vanilla case where is no conflicts. In this use case two, we cover the case where there is a conflict. So a conflict arises, for example, there is a main branch, and if we create two developers starts their activity by creating their own branches F1 and F2, and in bit before F2 without the knowledge of F2, in case if the F1, the developer F1 makes some changes in F1 and without discussing or collaborating with F2, if he merges the changes to main, F2 is become isolated with the changes that has recently happened with the main branch, and even he did not do a pull request also. That is, he did not attempt a pull also from the main branch. So in that case, he created the branch F2 from main, but the contents are not synced with main at the present state because in between after he created the F2 branch, some other changes has been pushed to the main branch. So the main branch is in a different state rather than the state when the F2 branch has been created. So when the F2 branch tries to attempt to merge with the main branch, a conflict occurs. So both the authors of F1 and F2 and the reviewer has to come, collaborate, and they have to resolve the conflict. Only then they'll be able to merge the conflict. So let us see how it's going to happen. I'm going to create two branches, F1 and F2, and consecutively without any gap from the main branch. And I'm going to update them. The user F1 is going to update the changes in the F1 branch, and then he's going to merge the changes to the main. And then F2, without witnessing the changes happen there, he will make a change in the F2 and attempt to merge. This will create a conflict, and we are going to witness now. So let's get into the repo. So the same repo, I am creating a two branches, F1, F2. So I'm again going to back to the main branch, and I'm creating the F2 branch also from main branch. So both F2 and F1 has the same content, which is derived, which is created from the base branch main. So now what I'm going to do, the user from F1 is making a changes from feature F1. I'm going to put F1 here and commit the change. So now from the F1, we are going to create a pull request to the main branch. Since there is no change to the main, since F1 is created, there is no conflict. And if I add a reviewer, and if reviewer approves, immediately I'll be able to merge. Sabha, can you approve?
Sure, sir. Yeah. It's been approved now.
Yeah. So Sabhavadi will also see a screen with approve button, and he approved. So that's why we are able to see the approved state here. Automatically it changes. Now I am going to merge the request. So the changes in the main now will reflect the changes that happen from the F1 branch. Now, without this anything aware of anything happened here, directly a user is assumed to make a changes in the F2 branch. Ideally, a developer, whenever he makes a changes to this branch, he should do a pull from the main. But in this case, let us say, for the sake of understanding, he makes a change without a pull. So he doesn't have the changes made recently to the main branch. He made the changes. Now he's creating a pull request. Base branch remains as main, and now automatically when he tries to create a pull request at this moment itself, he see can't automatically merge because the same line of the main has changed from the state it has been created, or it has did the last pull, create a pull request. So again, I'm adding a reviewer, creating the pull request. So it clearly says the branch has conflicts that needs to be resolved. Now, when I click resolve conflict, I can clearly see the two changes that went to main. One is the F1, the change after we created the pull request, there is a change that went to F1. is visible here. And now the second change that we tried to attempt from F2. So now I am asking reviewer which changes we need to maintain. So this has to be done a manual way because it has to be mutually agreed and then it has to be committed. So I'm asking the reviewer, like in this case, Sabha. So Sabha, do you agree which change you want to make it in the main?
So I would prefer to keep only changes from F2.
Okay. So with this feedback, I am also agreeing with Sabha and I am going to maintain only F2. So in this case, I'm going to delete the line number 2, 4, 5, and 6 and keep only 3. So the arrow and equal to symbols are just to give us an idea about from where the changes to resolve the conflict. So I am removing all the contents and keeping the only content that the reviewer is agreed with, the mutually agreed. Now I can mark as resolved, click commit merge. If you see in the main branch, the changes from the feature F1 is there, and I believe the merge the last merge is not yet merged. We have just resolved the conflict, but it is not yet merged. If we merge the conflict, we merge this change, and now if you go back to the main branch, you see the changes from F2 is reflects here. So whenever the pull request is merged, if there is a conflict, if we resolve the conflict and then it merged, the changes that we mutually agree and we push, that changes will alone come to the as a merge after the merge has been closed or the merge request being closed. So this by this stage, we could understand how to resolve conflicts and do close the merge request. All right. One more important point to note here is like, as a best practices, if developer creates a pull, not a pull request, this is a pull, just a pull. If he does a pull from the branch where he created the base branch from where he created the new branch, if he does the pull, this will avoid this kind of conflicts. And also, even if we get into such a kind of conflict, we know how to resolve it. Hope this session makes clarity in pull request and how to merge, how to resolve the conflict. Thank you. Thank you, Sabha.
Yeah, thank you, Sri. Thank you, everyone.